Hey, welcome back. We'll go ahead and close out today's lesson by beginning our discussion on initialization and assignment. So let me pull this up. Okay. So initialization and assignment. I'm going to think about these very different kind of from one another, as very separate processes, because this is going to help make things a bit more conceptually easier to understand once we get to classes. If you're familiar with the terms of copy assignment operator, copy constructor, you might understand why I'm making this distinction, so apparent early on here with even the primitive types. But for our first pass, let's go ahead and consider a variable as a small box and a value is something tangible like a coin, and assume that our box can hold a single coin. Before initialization, that box is empty. We pull it off the shelf, and during initialization, we can put a coin in it. And then from that point forward, the box is always going to contain a coin. If we wanted to assign or give that box a new coin, you first have to take out the old coin in order to put the new one in. And you can kind of think about this as kind of the processes behind initialization and assignment. It works more or less, but it's not exactly precise in terms of how things are actually working under the hood. So when we talk about initialization, think about starting out with. We're giving a variable its initial value, so we're always going to have type specification in that statement, because we give a variable its initial value in a declaration. Declaration always specifies the type of the variable. So when an initializer is specified in the declaration, the initializer is going to determine the initial value that object is going to start out with. So here, A is going to start out with. So from the point of declaration forward, it has the value of 5n until we change it. When no initializer is present for a local variable, and there's some distinctions when you're looking at other classes of variables, we'll call them, but for local variables, the variable will not contain a well-defined value. So you could think about this as, this might not be the best analogy, but you grab a box off the shelf and you say, this is kind of the box where I'm going to store my coin. You might get lucky and have an empty box and there's nothing in it, though there is the possibility that you could have got a box that was used by someone else. In C++, there's no zeroing out of memory after we kind of return or give back our boxes per se. So if you get something that someone else has used, the value that you might look when you inspect it for the first time, it's not guaranteed to be 0. Now, with that said, if we always provide an initializer, again, like here, we're guaranteed from the point forward that we know what A is starting out with. It has a well-defined value, and we've assigned it as, or we've initialized it as such. Excuse me. So looking back down here, we want to avoid this as kind of all cost. We always want to initialize variables of primitive type so that they're always starting out with a well-defined value. And again, this kind of gets back to our discussion on scope. Like, if you don't know the value that A is going to take on until you hit, this line, and assume there's like, I don't know, a gap here, we could say, just declare A here. That way we don't inadvertently do something like A's plus equal to 1. We just add 1 to, who knows, maybe it's 0, maybe it's something else. And if we inadvertently use it, this is going to be one kind of mistake that people will make that provides some bugs that are very hard to track down. And once you understand the stack a bit more and how memory for these local variables is allocated, you'll kind of get what's happening and why it might take a little while before things start to break. And then it makes it even more difficult to track down, the issues or to figure out, why things aren't functioning correctly. So just always follow the green, always initialize your variables. Don't do this declaration followed by assignment and leave this big gap of kind of unknownness. I mean, just don't go there. Save yourself, some time and effort potentially, and just always, always, always initialize these variables with well-defined values. And also, introduce the names when they're needed. Don't, introduce them all up front. And again, scope them as tightly as possible. If a name's not needed, throughout the whole function, but only within, say, inner scope to that function, go ahead and declare it where it's needed so that that name doesn't kind of pollute outside of where it's to be used. Okay, assignment. Assignment happens after we've declared and initialized our variables. It's giving a variable a new value. So in this case, it's not going to have type specification. So looking at this example, this is initialization. It always is. We can always tell because it's happening in a declaration. This statement here, A is equal to 8, we don't see any sort of type specification, and that's we'd expect in a declaration. So we know assignment is taking place here. So A, right when we hit this line, is taking on the value of 8. So from that line forward, A would evaluate to 8. Before we made that assignment, the initial value of A was 5. And again, this is what we want to avoid here. Some individuals will say that this is initialization here because it is the first time B is getting its value, but this is incorrect for C++, because B's already been declared, it's already been defined, and it's taken, so it's had memory allocated for it, so it has a value. If you write right here, let's just go C out B, that's simply printing the contents of B. B will evaluate to its value. That value will be inserted to the stream bound to standard output. Think back to hello world. If we write that, it's not guaranteed that B is going to be 0. It could be anything at this point. Whatever was, if we pulled the shoebox off the dresser and we want to reuse it for something else, who knows what's inside, for the, I guess, shoebox, whatever. Just thinking about the coin example, right? It's you're not guaranteed to have an empty box. It could be in use and you have to clear. And basically, if the first time you use it, you put what you want into it, from that point forward, the box contains what you want. If you just pull it off the dresser, set it somewhere without without putting in a value, I mean, who knows what's in it, and you won't know until you actually, open it up and see. So again, avoid this declaration followed by an assignment. Really go with the idea of initializing all your objects of all your variables of the primitive type, and do avoid this because this will get you in trouble. But again, the primary takeaway from this is that initialization, you're essentially you're essentially setting what a object's value is going to be or start out with. Assignment is going back and updating that value so that it now stores something else. So I hope that was productive and beneficial. Second lesson's done, on to the third.